Hello everyone and welcome to another episode on this very channel. In today's tutorials, we shall be looking at what we call mutually exclusive events, MEE, mutually exclusive events. So what is it? When we talk about mutually exclusive events, they are referring to an event we do not have anything in common or events we do not share anything in common. In other words, an event which cannot happen at the same time or an event which cannot occur simultaneously. Examples of mutually exclusive events is the flipping of a coin. We all know that when we toss or flip a coin, it is either we get a head or a tail. This means that when we toss a coin, we can get a head at a time or a tail at a time, but not head and tail occurring at the same time. It is not possible. So, tossing a coin and obtaining a head and tail at the same time are mutually exclusive events because these two outcomes can't happen at the same time. Another example of a mutually exclusive event is the tossing of a die. We know that when we toss a die, it is either we get the number 1, 2, 3, 4, 5, or 6. It can't happen that we are tossing the die and then we are getting 2 of the outcomes appearing at the same time. It can't happen in that way. So when we toss the die, one of these outcomes is going to pop up. It is going to show. But 2 or 3 of these outcomes can't appear or can't show at the same time. So tossing a die and obtaining 2 outcomes is a mutually exclusive event. An example is tossing the die and obtaining the number 2 and 5. It is not possible. Tossing the die and obtaining the number 3 and then 6. It is not possible. You can't toss a die and then obtain 3 and 6 all appearing on the die. It is not possible. It is either one of these appears. So tossing a die and obtaining the number 2 and then 6 are mutually exclusive events. Another example of a mutually exclusive event is picking a marble from a bag with different colors. So let's assume that we are having a bag which contains different colors. So this is our bag. And this bag contains different colors. Let's say green, and then let's say red. So if we are to pick a marble from this bag at random, it is either we are going to pick a green marble or a red marble, but not a green and red marble at the same time. It can't happen. It is either that we are going to pick a marble which is green or a marble which is red, but we can't pick a marble which is green and red at the same time. So picking a marble from a bag and obtaining a green and red color are mutually exclusive events. So these are examples of mutually exclusive events. If A and B are mutually exclusive events, then the probability of obtaining A or B, which is the same as A or B, is obtained by adding their individual probabilities together. So you have probability of A plus the probability of. So as I said, if event A and event B are mutually exclusive, then the probability of obtaining A union B or A or B is given as or is obtained by adding their individual probabilities together. So with that, let's consider this sets, a set of 1, 2, 3, 4, 5, or 6. And then let's look at event A, which contains, and then we have event B with the elements 6. We want to find the probability of obtaining A union B. Now first you have to ask yourself, do they have something in common? Do they share something in common? Can we have an element that belongs to A and belongs to B at the same time? We can see that we don't have any element that belongs to A and then belongs to B at the same time. So event A and event B are mutually exclusive events. In that case, their intersection, A intersection B, will give us an empty set. Since event A and event B are mutually exclusive, then the probability of obtaining A or B is given as probability of A plus probability of. Now, if we are to use the Venn diagram to represent these two events, this is what we are going to have. So these are sample space, these are event A, and this was our event B. Since these two events A and B do not have anything in common, their intersection is 0, then these two events are going to be a disjoint event. So we are going to have this and then that. With event A we have 3, 4, and then 5, and then event B we have 6. So you can see that these two events do not have anything in common and therefore their intersection is 0. So we have a disjoint event. To find the probability of A or B, we have to find the probability of A and then we have probability of B. Probability of A, so we have 3 all over the total number of outcomes in the sample space, and that is 6. So we have 3 all over 6, and then probability of B, we have 1 all over 6, and this is giving us 4 all over 6, which is the same as 2. So let's verify this rule using our knowledge in set. In set, when we are being asked to find A union B, what does it mean? It means that we are to put set A and then set B together. So this is what we are going to have: 3, 4, 5, and then 6. So this is A union B. Now, if we are to find the probability of A union B, then it is going to be the number of outcomes in A union B all over the total number of outcomes in the sample space. So we have 1, 2, 3, 4, 4 all over 6. And when you simplify, we have 2 all over 3. So this implies that this rule makes sense. So in all, we can say that when two events are mutually exclusive events, to find the probability of A or B, we just have to add their individual probabilities together and then we are good to go. Let's look at non-mutually exclusive events. When we talk about non-mutually exclusive events, then we are referring to an event which shares something in common. In other words, these two events can occur at the same time. An example of non-mutually exclusive event is the toss of a die and then obtaining the number 2 and then even numbers. So when we toss a die, we are going to get the number 1, 2, 3, 4, 5, or 6. And then we want to obtain the number 2. So let's use A for the number 2. So we have the number 2 here. And then let's use B to represent what? Even numbers from the toss of a die. So we have 2, 4, and then 6. When we look at event A and then event B, or set A and then set B, do they have something in common? Do they share a common element? You can see that we have an element that belongs to A and then belongs to B. So we have our A intersection B will be equal to what? 2. Since event A and event B have something in common, and that is 2, we can say that event A and event B are non-mutually exclusive events because they share something in common. So in finding the probability from a non-mutually exclusive event, we can say that the probability of A or B occurring, which is the same as, is given as the probability of A plus the probability of B minus probability of A intersection. So if we are to use the Venn diagram to represent this set, this is what it's going to look like. We have our sample space, we have our event A, our event B. Since they have something in common, the two circles are going to intersect. So we have our 2 here, and then we have 4 and then 6. So non-mutually exclusive event circles always intersect. So it always looks like this. If you have event A and then event B, you're always going to have this. And this is going to be your intersection. So we have non-mutually exclusive events. You always have an intersection. So you want to find the probability of obtaining A or B from this. So first we have to find probability of A. So we are going to have 1 all over 6, and then we find probability of B, 1, 2, 3 all over what, 6, and then we find probability of A intersection B, and that is what, 1 all over 6. So we are just going to plug in this in this formula. So we have 1 all over 6 plus 3 all over 6 minus 1 all over 6. So we are going to have 4 minus 1, we have 3 all over 6. So the probability of A or B occurring is 3 out of 6. So with this, we can also use our knowledge on set to verify if this rule is actually right or not. So in set, if we are being asked to find A union B, what does it mean? It means we have to put the elements in A and then in B together. So we are going to have 2, 4, and then 6. And then if we have to find the probability of A union B, we are going to have 1, 2, 3 all over what? 6. So this means that this rule is really right, very easy and then simple. This brings us to the end of today's lesson. See you tomorrow. Bye bye.